Chapter 7, and I have to give you guys a calendar. I almost forgot. Now, I did not get to print it in color. I hope you guys will make it. So when you take a look at this calendar, you will notice that Chapter 7 is like Fast and Furious. Chapter 7 only has 3 sections, which means if we do one section per day and 2 review days, the test is a week from today. So that's what I mean by Fast and Furious. It goes quick. So what we are going to be doing is we're going to start today with sort of the long way. Now I have known some students, let's make sure that you guys are all listening up. I have known some students to only do the long way. So we're going to learn the long way today. Then tomorrow and Thursday we're going to get like a formula. Tomorrow and Thursday the formula is in your packet and it will kind of be a shortcut. But today we're going to get sort of the long way. Even though this long way is actually a shortcut from stuff you already know, it's just not the shortest shortcut that exists. And so all of this stuff is about expanding binomials. And so this is definitely something that could come up on the IB test and definitely something that comes into play with the statistics and stuff that you might do next year. So, you can't even see the 7A part. Binomial expansions. Did everybody get their setbacks? So here are some things that we already know. We already know what a binomial is. A binomial is an expression that has 2 terms. Those terms are not like terms, so we can't like put them together. But so the most basic form you could get would be A plus B. You guys know what I mean when I say terms, right? I felt like second hour was like not quite sure. So like there's 2 terms because there's 2 things separated by this plus sign. Binomial. Now, the power of binomial is when we take that binomial, put it in parentheses, and raise it to a power. So this is to the nth power. And we know some shortcuts already, but I'm going to show you where those shortcuts we've already used come from and how you can kind of keep that pattern going to create more shortcuts for yourself today. So here are some of the shortcuts we already know. We know what to do when it's squared. So we have used this first one. I don't make it a requirement that you guys use it because you could always FOIL. But we have used this one this year. So if I have A plus B squared, I know that I square the first term, so A squared. I square the last term, B squared. And then to get my middle term, I multiply them both and times them by 2. So twice the product of both terms is your middle term. So we've done that. I thought that you guys have used the shortcut for cubes last year in trig, but second order didn't seem to know it, so maybe you haven't used it before. So sort of in a similar fashion, we cube the first term and we cube the last term for our numbers on the ends, but in the middle it's a little bit different, so we have to square part of it, multiply it by the other term, times it by 3, so it's a little bit different. But those are some shortcuts that you probably already used. I've purposely color-coded all this stuff, and we will take a look at that. Why did that coming up? I know some people are still writing. If you're done writing, do you see any patterns at all in the numbers? It could be in the red numbers and the coefficients. It could be patterns with the exponents. It could be patterns with the numbers of terms. Any patterns at all? Coming off the sequence and series chapter when we did a lot of looking at patterns, do you see any patterns at all? Ooh. All right, so Carrie found one that will come up later. There's one more term than like the expansion number. So for example, this is to the 3rd power. There are 4 terms. 1, 2, 3, and 4. That's the 2nd power. We have 3 terms. 1, 2, 3. That's definitely a pattern I was hoping you guys would see. So there's one more term than like the exponent. Yep.
In the first one, it's 2, 1, 1, 2, and in the second one, it's 3, 2, 1, 1, 2, 3 for exponents.
Okay, sorry, I had to had to slowly repeat what you said in my mind. So he's noticed that the exponents are sort of symmetrical, if you will. So 2, 1, yeah, it is. 2, 1, and then 1, 2. So it's kind of like a linear reflection in a way. And then here it's 3, 2, 1, and 1, 2, 3. That's interesting. I want to see if that works later. It might not, but it's still a good observation. Anyone else recognize or actually I think it is. We'll see. Any other observations at all? What? What did you say? Oh, okay. So like in this first one, she noticed that it's the second power. There are 2 A's and there are 2 B's. Is that fair? And this third one, there are 3 A's and then 3 B's. That pattern will continue as well, actually, I believe. We'll take a look. Okay, so let's take a look at the exponents. So I noticed that this is 3. What's the total of the exponents if we add these up? What's the total of these? And what's that one? Oh, okay. Does it work up here? Sure enough, 2, 2, and 2. So the sum of your exponents is the same as the power. So that's going to be the same as we go forward here. Someone in second hour noticed that the coefficients, the red numbers, get bigger towards the middle. So like the ones are on the outside, the middle is 2, 1, and 3. So like the numbers in the middle are bigger. And that pattern will continue as well. And so we're first going to look at the pattern for the coefficients, the red numbers. So these numbers, 1, 2, 1, and 1, 3, 3, 1, don't come out of thin air. They actually come from something called Pascal's Triangle. And I tried to make it look like a triangle as much as I could on here. But, using technology is not always easy. But we can use this pattern to find the coefficients for the binomial expansions. So if n equals 0, if it's to a power of 0, we know anything to the power of 0 just equals 1. If n equals 1, I'm not multiplying anything, so my coefficients are still 1. If n equals 2, if I'm on the second level, like level 2 here, notice 1, 2, 1 are the same exact numbers as the coefficients that we were just looking at when it was to the second power. Level 3, it's at 1, 3, 3, 1. So level 3 is, we add those coefficients, and then I have the fourth level here, so if we're taking it up to the fourth power, the coefficients will be 1, 4, 6, 4, and 1. Another pattern, like the pattern that Carrie brought up, so since I've got to the fourth power, notice there are 1, 2, 3, 4, 5 terms. I do recommend writing this down. We are going to expand it to the 5th, maybe 6th. I would say we'll get to that later, but it would be in your benefit to be able to take this out to the 6th level. So if you want to keep it nice in your notes, take it all the way out to 6 and we can fill it in later. After you guys, I'm going to give you some time to write this down, but again, once you have it written down, if you can see any patterns or any connections between the numbers of the levels, like how do we get to the next level, and kind of see if you see any patterns there. Okay, anyone see any patterns of how we can like find like the next numbers, like any connections between the rows? I will tell you, but I just wanted to see if anyone could see it. What do you think, Tim? Exactly. Well, a little bit different, not the last one. Everything else is good though, because I would be actually adding these two. But so you add the 2 above it. So for example, 1 plus 1 is 2. All right? 1 plus 2 is 3. Over here, 2 plus 1 is 3. Do you guys see where I'm going with this? So we get 4 because we do 3 plus 1 is 4. And I know it's not perfectly centered again. I tried. Okay? And 3 plus 3 is how we get 6. And 1 plus 3 is how we get 4. Now, the ones on the ends, because there's nothing to add with. 1 plus nothing is 1. Okay? So we can keep that pattern going on indefinitely, and before we're done with notes, we'll get the 5th level and maybe the 6th level written down if you guys want help with that. But that pattern can keep going. Now that's the coefficient. So what we're going to talk about next is how you can find like the A's and the B's in the middle. So we'll end up putting the A's and B's in the middle on our next step here. But are there any questions about how you get those numbers? Okay. So now the A's and the B's look like this. So if I have A plus B to the 4th power. Again, I've done my coefficients all in red throughout these notes. So we've got 1, 4, 6, 4, 1, just like it was from the triangle. And then I'm going to give you guys a moment to write it down, and then I'll explain how we get the A's and the B's, so that you guys can, moving forward, kind of create this on your own. So we start with A, and we start with the power of the expansion. So this is to the 4th power, so we'll start with 4. And we start with A, and the powers go down slowly, one by one. So A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, and I don't need to write down A to the 0. The B's sort of go in reverse. Now I don't have any B's on the first one, this would be B to the 0, but then the B's are going up. So B to the 1st power, B to the 2nd power, B to the 3rd power, and I finish out with B to the 4th power. So the largest power, 4th power, is going to match the power on your expansion. Then, if you are not quite sure, just double check that your powers all add up to the expansion number. So this is expansion to the 4th power. So then just double check. Sure enough, 3 plus 1 equals 4. 2 plus 2 equals 4. 1 plus 3 equals 4. So that's like a little check to make sure that you've got the right powers on all of those different parts. So that's how we can come up with a shortcut. We're going to use it in an example with real numbers next. Okay? So we're going to use Pascal's triangle to expand 7 plus k to the 4th power. And so I'm going to do it without looking directly at the formula. It's in your notes, so you can look at that. But I'm going to kind of go through the process without looking directly at the formula, just to sort of help you guys be able to do that. So keeping in mind that this is like A plus B here, right? I mean, it's still to the 4th power. So you can kind of use that if you need help to go back to your formula. But if you don't have your formula in front of you, maybe you just have Pascal's triangle. Because I have known students to draw a big Pascal's triangle and go out to maybe the 10th level or something, which is totally fine for your homework, but you're not going to have that on the test. And we're going to get into more details about that as we move on in this chapter. But if I have that Pascal's triangle, first I look at level 4, and I see on level 4, these are my constants. 1, 4, 6, 4, and 1. So that you don't have to really memorize. You can look at your triangle, or if you need to sketch out your triangle to that level, you can do that. Are we all okay there? Then we can take our powers, our A's and B's, and we can put the powers on them. So remember, when you start with A, you start with the biggest power, the power of your expansion. Well, this is going to the 4th power, so I would have A to the 4th power. And then that just drops down. So A to the 3rd power, a to the second power, a to the first power, and then I don't need to write down a to the 0 power. Except for I screwed it up. What am I supposed to put in there? What's a? 7. Okay, let me fix that. Definitely want to put that number in there, not just the a. Sometimes they get more complicated, so that's why I've got parentheses, just in case I have like a negative. I don't have any negatives here, but that's typically how I do it, just in case. And then I can put the b part, which is k. Now remember, there's no k in the first part, and then I start with 1 and I work on up. And I can double check, okay, 3 plus 1 is 4. So I know I have the right exponents here. And now k goes to k squared, and then k to the 3rd power, and lastly k to the 4th power. Alright, that was supposed to be 7 to the 1st power. I don't know what I had going on there. So besides that, I put in a instead of 7. We have questions. We're not done because we still have to simplify. We still have to simplify so our numbers are a little bit nicer. But I definitely see some curious looks. So if you have a question, please let me know. I didn't do a lot of examples because I want you guys to kind of work through on your assignment. So keep in mind the a part of the term is going 7 to the 4th, to the 3rd, to the 2nd, to the 1st, and then the k part's going up. Now after that, you do want to simplify your coefficients, so we always have to remember PEMDAS. So remember, do your exponents first, and then multiply. So 7 to the 4th power is a rather large number. You can use your calculator to calculate 7 to the 4th power. So I've got 2,401. And then here, you want to make sure that we do our exponents first. So 7 cubed, and then take 7 cubed and times it by 4. To get 1,372. Don't forget the k. Now, if you're not getting the same numbers as me, just make sure that you check that you're doing your exponent first and then multiplying. So on the next one, I'm going to do 7 squared is 49, and then 49 times 6 is 294. Don't forget my k squared. Then I've got 7 to the 1st power. Well, that's just 7. 7 times 4 is 28, and then I've got 28k cubed. And then I end with k to the 4th power. So that's my answer after I've simplified all of those coefficients. Sometimes, depending on how complicated it is, I might, sometimes I slow it down more just because that's how I am, but this one we didn't really need to. Sometimes I might do all of my exponents and then do my multiplying on the next step, just kind of depending, but you can kind of get a feel for what works for you. Other questions? Now, it is a little bit of a shortcut because otherwise we would have had 7 plus k times 7 plus k times 7 plus k times 7 plus k. What would have been your alternative? We'd have to FOIL twice. And then I'd have to do a trinomial times a trinomial and combine all those terms. So even though it's still not our shortest shortcut that we've got coming, but it's still a shortcut compared to what we used to do. Are there any questions? Remember, this is a really fast chapter, so you don't have a lot of time to make sure you're asking those questions. All right, so your stat box is actually to write down the next line in Pascal's Triangle. So if you don't want to write it in your stat box, you could put it in your chart if you want to. What would be the next line? And I'll write down the n equals 4 line. So when n equals 4, it was 1, 4, 6, 4, and 1. So expand to the 5th power. And you will go all the way up out to the 6th power on your assignment. So do you want to do the 6th power too? So what would the coefficients look like for the 5th row? So I start with 1. So what's my next number? Good, because I do 1 plus 4 is 5. So then what's next?
10. 5.
So do you guys see how that works? So you could keep it going if you wanted to. So if we did want to do the 6th one, I have 1. 9, 10 plus 10 is 20. Do you guys need any help with like the A's and B's? Okay. All right. So just keep in mind if you are kind of having an issue, just start with the power. So that'll be 5th, and then these just drop down. And then the B's pick up. And I don't have a lot of space. Oh, 1, 2, 3, 4, and then I've got to the 5th. So just to kind of keep that in mind as you guys go forward here. So we're going to learn some different formulas for when we have to go even further, but for right now, you're practicing with Pascal's triangle.